All right, in this podcast, we're going to talk about oxidation and reduction half reactions. All right, so half reactions basically allow us to focus on one of these species at a time, either the one that's being oxidized or the one that's being reduced. And then we're able to combine the equations to get the overall balanced redox reaction. All right, so there are some steps for writing balanced redox half reactions. So first we're going to write the unbalanced equation in ionic form. We're going to separate the half reactions for oxidation and reduction processes. Then we're going to balance the atoms in the half reactions. Then we will add enough electrons to one side of each of the half reactions in order to balance the charges. And then we're going to multiply each half reaction by an appropriate number in order to make the number of electrons equal between the reduction and the oxidation reaction. Okay, so here we go. All right, so we got copper. Okay, so we know this has got oxidation is 0, oxidation number is 0. Our fluorines are 1 minus. That means the Ag has to be 1 plus, and the copper is 2 plus. So I need to pull out my copper species. So I've got my copper, and that is going to copper 2 plus over here. And then I have my, my Ags. Okay, so my Ags, this one is 1 plus, and then it's going to AgO. All right, now my atoms are balanced. I have 1 copper, 1 copper, 1 silver, 1 silver. Now I need to add electrons. So we're going to abbreviate electrons as E with a little negative sign. Okay, so in order to make my charges equal on both sides, or charge balance. So this side I have a 0 charge, and on this side I have a 2 plus charge. So I need to add 2 electrons over here, and that will cancel out that 2 plus. So 2 plus 2 minus gives me 0, and my other side was 0. Okay, and we obviously know that this is losing electrons, and oxidation is losing. So this is our oxidation half reaction. Okay, now my silver. So this side over here is 0, and then we have a 1 plus. So I definitely need to add an electron over here. And because we are gaining electrons, that is the reduction half reaction. All right, so all my atoms are balanced. Now I need to make sure, and my charges are balanced. Now I need to make sure that I have equivalent number of electrons. So over here, I have 2 electrons. So I've got to get Ag to 2 electrons. So I'm going to multiply the entire equation by 2. And now I have 2 electrons and 2 electrons. All right. So this one, we know that calcium and oxygen both have a 0 charge, or 0 oxidation number over there. Over here, they have 2 plus and 2 minus. Okay, so I'm going to pull my CAs out first. So I got my Ca, and my Ca is going to Ca 2 plus. And I'm going to go ahead and charge balance it. So I'm going to need 2 electrons to balance out that 2 plus. All right, now I can look at my oxygen. So I have O2. And then over here, I have O2 minus. Need to balance my atoms first. So I need to get 2 oxygens on that side. Now I need to make sure that my charges are balanced. So over here I have a 4 minus charge. So I need 4 electrons over here. In order to do that, which means I need to go back and multiply this guy by 2, and that becomes 4 electrons. All right, now everything's balanced. And let's see, the top equation, I am losing electrons, so that is oxidation. And the bottom equation, I'm gaining electrons, and gaining is reduction. All right, next example. Okay, so we have worked on this one a time or two, I believe. So definitely got our 1 plus 1 minus, 1 plus 2 minus, 5 plus on that nitrogen, 2 minus, 1 plus. So that's a 3 plus on that end. And then 1 plus 2 minus gives us a, let's see, 5 plus on that chlorine. Okay, so need to pull my chlorine species out for sure. So I got a chlorine 5 plus. And then on this other side, I have my chlorine 1 minus. Okay, so in order to, my atoms are balanced, but I do need some electrons here. I've got to go all the way from 5 plus to 1 minus. So that is going to be 6 electrons. Because that'll cancel out that 5 plus and give me 1 extra negative. All right, now let's look at our ends. So nitrogen is 3 plus. And then over here, it is 5 plus. Okay, so to get from 3 plus to 5 plus, we had to lose an additional 2 electrons. Okay, so at this point, both equations, charge balanced and atom balanced. Now I need to get my electrons to balance. So I need 6, I only have 2, so I'm going to multiply everybody in this equation by 3. Oops, and I don't know why I wrote that, but 3 times 2 is 6. So 6 electrons. Now I have 6 electrons and 6 electrons. All right, the top one is gaining. So reduction is gaining. And the bottom one is losing. So oxidation is losing. All right, and lastly, we have our PB and our S, and then over here our PB and our O, and our O, and our S. Okay, so the only guys that are changing here are the S's and the O's. Okay, so I'll start with my S's. So I've got an S2 minus. And then over here, it is turning into a S4 plus. Okay, so to get it from 4 plus to 2 minus, I'm going to have to add 6 electrons. Okay, now on to my O's. So I have O2, and my O2 is turning into O2 minus on this side. I'm going to go ahead and balance my atoms. So now I have 2 oxygens on each side. Now I need to charge balance. So with putting that 2 in front, now I have 2 times negative 2. So that'd be negative 4. So I need 4 electrons over here. Okay, so we're charge balanced, we're atom balanced. Now we got to get our electrons to match. So what number can I go to that 4 and 6 have in common? Hopefully you thought of the number 12. So to get to 12, I would put a 2, and then obviously this would be 12. And then to get 4 to 12, I'm going to do a 3. And 3 times 2 will give me 6. All right, there you go.